The Nevada test range had no name on any public map. It appeared on classified military documents simply as Site 14, Bravo, a designation that told you nothing and was meant to tell you nothing. It sat roughly 60 miles southeast of Reno, wedged between two low ridgelines that shimmered and dissolved in the August heat. The coordinates were redacted from the base's own maintenance logs. Civilian satellite imagery of the region had been quietly licensed for use by a government contractor and then quietly altered. The facility showed up as a flat, featureless expanse of alkali flat, the same color and texture as the desert floor around it. There was nothing there. Nothing had ever been there, except, of course, for everything that was there now. Colonel Raymond Voss arrived at 0530 hours, 2 hours before the rest of the team. That was his way. He drove himself out from the main base in a matte black government SUV, windows up, air conditioning on full, and he sat for 10 minutes in the parking bay staring at the facility before he got out. It was already 94 degrees. By noon it would be 114. The forecast said 118 by mid-afternoon, possibly higher, and the forecast was probably wrong in the optimistic direction. Voss was 53 years old. He had done 3 tours in Iraq and 2 in Afghanistan and a number of other assignments in locations that did not appear on his service record. He had gray eyes the color of old concrete and a face that had been cut from the same material. He did not believe in luck. He did not believe in instinct. He believed in systems, in data, in verified and repeatable processes. He had spent the last 8 years of his career shepherding the AIRS program adaptive range engagement system from a theoretical framework into operational hardware, and today was the culmination of that work. Dr. Ethan Marsh arrived 20 minutes later with his team, 6 engineers from the Advanced Weapons Research Group at Fort Belvoir, 3 software developers from the AI Integration Division at DARPA, and a logistics coordinator named Brett Sully, who had a master's degree in mechanical engineering and made the best coffee in the building. They moved with the efficient, slightly manic energy of people who have been working towards something for a very long time and have finally arrived at the moment when it either works or it doesn't. The AIRS platform was already set up on the main firing line. From a distance, it didn't look like much. A squat, low-profile chassis on a stabilized mounting platform, roughly the size and shape of a large suitcase lying on its side, connected by cables to a processing unit housed in a ruggedized transport case. The actual barrel assembly was a custom-manufactured .50 caliber precision rifle integrated directly into the chassis, designed to eliminate the variables of human interface. No hand gripping a stock, no cheek pressed to a pad, no eye squinting through an optical system. The rifle was part of the machine, and the machine calculated everything. Thermal sensors read ambient air temperature at 17 points along the projected ballistic path. Micro-anemometers mounted on a 40-foot mast measured wind speed and direction at 4 vertical intervals simultaneously. A LiDAR unit built into the chassis calculated exact distance to target with an error margin of plus or minus 3 centimeters. An onboard AI, the result of 4 years of machine learning on over 12 million historical rounds fired under controlled and field conditions, synthesized all of this data in real time, adjusted for barrel wear, ammunition lot variance, Coriolis effect, and what the system documentation called atmospheric density gradient modeling, which was a way of saying that the system could account for the fact that air at different temperatures along the ballistic path had different densities and therefore different effects on a projectile's flight. The target was a steel silhouette plate, 30 inches by 20 inches, mounted on a precision surveyed stake at exactly 3,218 meters, 2 miles and a fraction. The distance had been chosen deliberately. It was roughly the outer edge of practical precision engagement for a human operator using traditional long-range equipment. At that distance, a round traveled for approximately 4 seconds before reaching its destination. A lot could happen to a round in 4 seconds. Voss walked the firing line. He stopped at the platform. He looked at the target. It was barely visible at this distance, a thin vertical smear against the base of the far ridgeline, invisible in any meaningful detail. Atmospheric conditions, he said. Marsh checked his tablet. Ground temp is 94 and climbing. Wind at ground level is 2 to 4 miles per hour. Variable direction. Wind at 20 feet is 6 to 9, predominantly east-southeast. Wind at 40 feet, he paused. Wind at 40 feet is 12 to 14, same predominant direction. Refraction index, high. Heat shimmer starts at about 800 meters and intensifies significantly from 1200 outward. The system's thermal correction algorithms account for it. Voss looked at the horizon. The air above the desert floor was already moving, the heat pulling it upward in slow, undulating columns that made the far ridgeline appear to breathe. He had seen this before. The way the desert swallowed distance, made it elastic and unreliable, turned solid geography into something that shifted and pulsed like a living thing. Timeline, he said. First test round at 0800 hours, Marsh said. System needs approximately 6 minutes to complete full environmental calibration. We run 3 rounds. Assess, adjust, if needed, run 3 more. We won't need to adjust. Marsh looked at him. I'd like to have the protocol in place just in case. We won't need to adjust, Voss said again. It wasn't a rebuke, it was simply his conviction, stated in the same tone he used to state everything. The system has processed more atmospheric data than any human operator will encounter in a lifetime of shooting. What we're seeing out there, he gestured at the shimmer rising from the flats, is exactly the environment the AI was trained for. Heat, distance, atmospheric distortion. This is what it does. Marsh nodded slowly. Behind him, his team moved around the platform with the careful purposefulness of surgeons preparing an operating room. Voss turned and walked back toward the shade structure at the rear of the firing line. He poured himself a cup of Sully's coffee. He watched the heat rise. The human element is the problem, he said, not to anyone in particular, always has been. You put a person behind a rifle and you get fatigue, fear, distraction, inconsistency. You get a bad breakfast, or a poor night's sleep, or a memory that surfaces at the wrong moment. You get a nervous system that can't be optimized. He took a drink of his coffee. The machine doesn't get tired. The machine doesn't think about anything else. The machine just calculates. No one answered. No one felt the need to. The air system completed its environmental calibration at 0756 hours, 4 minutes ahead of schedule. Marsh stood at the primary monitor, watching the data streams. Temperature gradients across 17 sensor points, logged and modeled. Wind velocity at 4 vertical intervals, logged and modeled. Atmospheric pressure, humidity, barometric trend, logged and modeled. The LiDAR return from the target had already been processed. Distance confirmed at 3,218.4 meters, a 0.4 meter variance from the surveyed distance within the ARES system's expected tolerance. On the monitor, the targeting solution was displayed as a green circle over the digitally enhanced camera feed showing the target. The circle sat precisely centered on the steel plate. System reports full confidence, Marsh said. No flagged variables. Understood, Voss said. He was standing 6 feet behind the platform with his arms folded across his chest. Fire when ready. Marsh gave the command. The ARES platform made almost no sound when it fired. There was a sharp, contained crack far less dramatic than a conventional rifle discharge, followed immediately by the mechanical clatter of the self-loading mechanism. The round was in the air before the sound had finished reaching the observation team. 4 seconds and a fraction. The target downrange did not move. Marsh looked at the monitor. The impact sensor on the target steel, a pressure-sensitive strip bonded to the face of the plate, had returned no data. The shot had not struck the target. The silence that followed was of a particular quality. Not the silence of something that had simply not worked yet. The silence of something that should have been impossible, and wasn't. Voss said nothing. His expression did not change. Run diagnostic, Marsh said quietly. The diagnostic took 90 seconds. The team moved around the platform with their tablets, their faces showing the controlled, careful expression of people who understood exactly how much was riding on what they were looking at. Brett Sully walked downrange on foot to check the target and the surrounding area. He came back without finding an impact crater anywhere near the plate. No hardware fault detected, one of the engineers said. The system fired as commanded. Ballistics calculation was executed correctly by the algorithm. Then why did it miss? Voss asked. We're looking at that. Look faster. Marsh studied the data. The targeting solution had been built on the atmospheric readings from 0756 hours. In the 12 minutes since calibration completed, ground temperature had risen by 3 degrees. More significantly, he saw it now. In the post-shot analysis, there had been a transient wind event at the lowest measurement interval, a brief but sharp shift in direction from east-southeast to south that had lasted approximately 2 seconds and then reversed. The air sensors had caught it. The algorithm had evaluated it and, following its training parameters, classified it as a transient anomaly, a gust, and continued with the previously calculated solution. The algorithm had been wrong to do so. It classified the low-level wind shift as noise, Marsh said. He kept his voice professional and controlled. The algorithm assigned it a low confidence weight because it contradicted the data from the higher measurement points. Standard gust rejection protocol, and the algorithm was wrong. In this specific instance, yes, the shift at the lowest interval was a separate airflow phenomenon, not related to the higher level wind profile. In normal range conditions at normal temperatures, those two things move together. In this heat, with this degree of thermal layering, they can decouple. Voss was quiet for a moment. Adjust the parameters and fire again. The second shot was fired at 0823 hours. The impact sensor on the target did not register. Sully walked downrange again. He found a mark in the dirt approximately 4 meters to the right of the target plate and slightly below its center height. The round had traveled 3,218 meters and arrived 4 meters away from where it was supposed to be. 4 meters, Voss said. At this distance, Marsh began. 4 meters, Voss said again. The engineering team gathered around the primary monitor. They spoke in low, rapid voices. They pulled up the shot data, overlaid the atmospheric readings, ran the trajectory backward from the observed impact point. The problem was visible in the data once you knew where to look. The thermal gradient between ground level and 8 feet above ground had created a wind shear layer that the system was systematically misinterpreting. The AI had been trained on range data where this shear layer was not present, or was present only in mild form, because no one had ever tested the system in 110-degree desert heat. No one had thought to. Third round, Voss said. Colonel, I'd recommend we adjust the algorithm weighting before. Third round. The third round was fired at 0841 hours. Ground temperature was now 107 degrees. The heat shimmer above the flat was violent, the air above the desert floor moving in heavy, slow waves. The impact sensor on the target did not register. For the first time since the test began, Colonel Raymond Voss looked at the ARS platform without folding his arms. He stood with his hands at his sides, which, for him, was a different posture. His face still gave nothing away, but his hands, loose at his sides, said something. "Stand down," he said. "Recalibrate." The medical support vehicle arrived at 0930 hours. It was a requirement at any live fire facility, emergency medical response on standby for the duration of any live test event. The vehicle that pulled through the perimeter gate was a civilian specification ambulance. Older, the white paint on its body oxidized by years of desert sun to something closer to bone. It parked at the designated bay at the far end of the facility's service road, engine off, no particular hurry about anything. The woman who got out was approximately 60 years old. She moved slowly. Not because she was frail, she moved the way old wood is solid, weight in it, deliberate, but because she was carrying a large cooler in both hands. She set the cooler on the ground beside the vehicle, opened it, and began sorting through its contents with the practiced efficiency of someone who had done this many times. Water, electrolyte packets, a small case of medical supplies. Her name was Martha Hale. She wore civilian-issue desert fatigues, faded, and a broad-brimmed hat that had seen considerable use. The skin of her forearms was tanned to a deep, settled brown. She wore no insignia, carried no equipment beyond the cooler and a small medical bag over one shoulder. She looked exactly like what she was supposed to look like, a contract medical support staff member, civilian, doing her job. She walked toward the firing line without being directed there. She seemed to know where everything was. A young soldier, Private First Class Lucas Morrow, assigned to range security, intercepted her before she reached the restricted area. "Ma'am, this area is—" "I know what it is," she said. "I've got water and electrolyte packs for your people. In this heat, you'll lose a man to dehydration before noon if you're not careful." She looked at the ARES platform from where she stood. She looked at it the way you look at a problem you're already solving in your head. Morrow hesitated. Regulations said civilians stayed at the support bay, but she was right about the heat, and she had the medical support clearance. He escorted her to the shade structure and let her set down the cooler. She moved through the engineering team, distributing water, quiet and unhurried. She spoke when spoken to. She didn't speak otherwise. At some point, Morrow noticed this later, trying to reconstruct the sequence of events. She stopped beside the far edge of the shade structure and stood very still, facing the direction of the target. She stood there for a long time. Long enough that it became noticeable. She wasn't watching the equipment. She was watching the sand. Specifically, she was watching a low shelf of air roughly 3 feet above the surface of the desert floor, where the heat was creating a steady, subtle displacement that moved from left to right at a different speed than the wind at head height. Her eyes followed it. Her head tilted, very slightly, the way a dog tilts its head when it hears a sound that interests it. "You're not accounting for the low-level shear," she said. The nearest engineer, a young man named Daniel Hicks, looked up from his tablet. "Sorry, the air at ground level isn't moving the same direction as the air above it. The thermal gradient is decoupling the layers. Your system is reading the upper layer wind and using that for its ballistics calculation, but the round spends a significant portion of its flight below that layer." She nodded toward the desert floor. "Out there, it's worse. There's a microthermal running along the base of the far ridgeline that'll pull left at about the last 100 meters. That's why you're going right. You're correcting for a wind that stopped mattering 3 miles ago and ignoring the one that's doing the actual work." Hicks stared at her. "Ma'am," he said, carefully, "who are you?" "Medical support," she said. "You need to drink your water." Marsh heard about it secondhand from Hicks, who repeated it with the uncertain expression of someone who had received information they didn't know what to do with. Marsh crossed the shade structure in 6 steps and stood in front of Martha Hale. "You said you have an observation about our ballistics calculation," he said. Not unkindly, but not kindly either. The professional to civilian tone, precisely calibrated. "I made an observation," she said. "That's different. What's your background?" "Nursing. Emergency medicine. Previously." Marsh looked at her with the careful patience of a person who was choosing not to be impolite. "Our system uses 14 integrated atmospheric data streams, a machine learning model trained on 12 million historical rounds, and a targeting algorithm that accounts for every measurable variable in the flight path. We have a team of 8 engineers, 3 AI developers, and a director of ballistics research with a doctorate from MIT." He paused. "I say that not to dismiss you, but to give you a sense of the level of analysis that's already been applied to this problem." "I know," she said. "That's why I mentioned it. Because we couldn't see it? Because sometimes, the more you know, the harder it is to see something simple." She turned back toward the desert. "Your system is measuring the wind." "I'm reading it. Those aren't the same thing." "You're reading it," Marsh repeated. "The coyote sage on the flat out there, you see how it's moving at the base? Different rhythm from the tops of the stems. The ground thermal has its own circulation pattern. The sand itself tells you where it goes. Your sensors are mounted at 4 meters, 6 meters, 12 meters, and 40 meters. You don't have anything at ground level except the temperature sensor, and temperature isn't wind." She turned back to him. "The round drops below your lowest measurement point somewhere around 800 meters and doesn't come back up. You're flying blind for the last 2,400 meters of the shot." Marsh was quiet for a moment. Then he said, "Thank you for your input." The tone of it was not what the words said. She picked up her medical bag. "Drink your water," she said. Voss had been listening from the other side of the shade structure. He had not moved toward the conversation. When it ended, he walked slowly over to where Marsh stood. "What do you think?" Marsh asked quietly. "I think she's a nurse who watched us miss 3 shots and came up with an explanation that fits the available evidence," Voss said. "That's not the same as being right. Her description of the ground-level shear layer is consistent with what our post-shot analysis identified. Our analysis identifies it too. That's what the recalibration is for." Voss looked toward Martha, who had returned to the cooler and was rearranging its contents with total serenity. "The difference is that our analysis uses data. She's using," he paused, searching for the word, "experience?" Morrow suggested. He was standing nearby, close enough to hear, and he knew he should probably not have contributed to this conversation, but he said it anyway. Voss looked at him. "I was going to say guesswork," he said. He walked away. Morrow stayed where he was. He looked at Martha Hale. She had finished rearranging the cooler and was now sitting on its lid, hat brim pulled low, apparently unconcerned with everything that had just happened. "You weren't guessing," Morrow said, quietly. Not looking at her directly, she said nothing. After a moment, she looked toward the far ridgeline. "The light changes on that far slope about every 20 minutes, she said. "See how the shadow moves across the base? That tells you where the ground thermal column is cycling. You watch it long enough, you can time it." Morrow watched the slope. He couldn't see what she was seeing. Not yet, but he believed she was seeing it. The R's system ran 2 more rounds between 1,000 and 1,030 hours. Both missed. The 5th shot impacted approximately 2.5 meters to the right of the target plate. The 6th struck the dirt 3 meters short and slightly left, which was worse than the previous misses in a different way. It meant the correction introduced by the recalibration had overcorrected, then overcorrected the overcorrection. The system was chasing its own tail. Marsh sat at the primary monitor and did not speak for several minutes. Behind him, his team worked with the careful, concentrated energy of people who are afraid to show they are afraid. Voss stood at the edge of the shade structure, looking at the desert. Morrow had been watching Martha Hale for the past 2 hours. She had remained on the perimeter of the support area, sitting in the shade of the ambulance, doing nothing in particular. She had not approached the team again. She had not offered further observations. She drank water and looked at the desert and seemed perfectly content with whatever was happening inside her own head. Morrow made a decision. He walked over to the ambulance and sat down on the ground beside the cooler. "What would you need?" he asked, low. Not looking at her, she looked at him from under the brim of her hat. "What would you need to take the shot yourself?" he said. She was quiet for a long moment. "That's a strange question." "I don't think it is." The silence stretched. A dust devil spiraled up from the flat about 200 meters out, spun for a few seconds, and collapsed back into the sand. "A rifle," she said. "Something simple. Bolt action. Nothing with electronics." Morrow said nothing. He got up and walked toward the equipment bay at the rear of the facility. It took him 11 minutes to find what he was looking for. A Remington 700, 20 years old, fitted with a basic non-electronic scope. It was a range verification instrument, used occasionally to confirm target placement. It had not been fired in months. He carried it back under a canvas tarp, which was both unnecessary and somehow exactly right. When he set it down beside her, she looked at it for a long moment without touching it. Then she looked up at him. "You know this is going to go badly for you," she said. "Maybe," he said. "How old are you?" 23. She looked at him for another moment. Then she picked up the rifle. Voss saw it from across the facility. He went very still. Then he walked over with the slow, controlled deliberateness of a person working to keep an internal pressure from showing externally. "What?" he said. "Is that?" "I brought the range rifle from the equipment bay," Morrow said. "Ma'am had some observations about the shot." "I thought." "You thought." Voss looked at him. "You thought." "Yes, sir." Voss looked at Martha. She was holding the rifle the way a person holds a tool they know well, loose and certain, like it was simply an extension of her arm. He looked at that. He looked at it carefully. "You want to take a shot at the target?" he said. "No," she said. "I'm happy to go back to the ambulance. But you've spent the morning failing at something I believe I can do, and that makes me want to demonstrate that I can." She paused. "Not for you, for the young man standing behind you who's about to get in significant trouble for bringing me this rifle." Voss looked at Morrow. Morrow looked back at him without flinching. That, Voss thought, took a certain kind of nerve. He looked at Martha again. He looked at the rifle in her hands. And then he did the calculation that all military men eventually make. The calculation between pride and information. "One shot," he said. "If you miss, you put the rifle down and get back in your vehicle and don't speak to anyone on my team again." "Agreed," she said. "And if I hit," she said. He said, "We'll address that when it happens." The engineering team watched from the shade structure. No one spoke. Not because they had been told not to, but because watching her approach the firing line had somehow made speech feel inappropriate, like talking during something that was already in progress and had no need for commentary. She walked to the firing position without being directed there. She knew where to stand. She stood there and she did not set up quickly. She set up slowly, adjusting her position with small, precise movements. She placed her feet. She settled her weight. She raised the rifle to her shoulder and lowered it again and raised it again, finding the natural point of aim, the position from which her body, without effort, pointed the rifle where she wanted it to go. She seemed to be waiting for something, not for conditions to improve, for conditions to present themselves clearly. Hicks whispered to the engineer beside him, "She's not using any of the sensors." "She doesn't have any sensors," the engineer whispered back. "She's not even using a rangefinder. She knows the distance." "How?" No one answered that. The heat off the desert floor was now at its afternoon peak. The scope's lens, if she was using it for magnification, was looking through air that was no longer quite solid, a medium that flexed and breathed and shifted, that bent light along paths that did not match its origin points. At 3,218 meters, the steel plate was an abstraction. It was a theoretical object located at the end of a column of heated air. She was still. Her breathing had changed. It became slow and shallow and very regular, not controlled in the way that someone controls their breathing when they're working hard to do so, controlled in the way that breathing is controlled when the person has stopped thinking about it as a voluntary act. Her right hand was on the stock. Her left hand supported the fore-end. Her cheek rested against the comb. Her eye was close to the scope, but Morrow, watching from 8 feet away, noticed something. She was looking through the scope, but she was also looking past it. The scope was a reference point, not the source of her information. The actual information was coming from somewhere else. From the sum of everything she had been reading for the past 3 hours, the sand and the sage and the light on the far slope, and the dust devil patterns and the temperature and the weight of the air. She made one adjustment, small. She shifted the barrel perhaps half a degree up and left, then she stopped moving entirely. In the moment before she fired, the desert was absolutely quiet. The engineers had stopped breathing. Voss stood with his hands at his sides, not folded, the way he stood when something had taken him off his script. She fired. The report was sharper than the ARES platform's muted discharge. Old technology sound, uncollimated, radiating outward across the flat and reflecting back off the far ridgeline a second later. The impact sensor on the target plate triggered immediately. Center hit. The telemetry showed it. The round had struck within 6 inches of the geometric center of the 30-inch plate. The echo came back off the ridgeline. Then there was nothing. No sound. No movement. The air above the desert floor moved the way it had moved before, slow and indifferent. The target plate stood where it had always stood. No one spoke. Morrow watched them, watched Voss, watched Marsh, who was standing at the primary monitor with his hands at his sides, looking at the impact data, and whose face had a quality that Morrow had never seen on a scientist's face before. Not confusion, not anger, but something closer to the expression of a person standing in front of something true that they had been certain was impossible. The echo died away. Silence. Voss called it an assessment meeting. That was the language he used. The word interrogation would have implied that she had done something wrong, and whatever else was happening, she had not done anything wrong. She had hit a target at 3,218 meters with an unmagnified iron sight rifle he had checked, and the scope on the Remington 700 had developed a crack in the objective lens at some point, rendering it optically useless on a single shot, in conditions that had defeated a multi-million-dollar AI targeting system 6 consecutive times. He needed to understand what had happened. He sat across from her at a folding table in the facility's small briefing room. Marsh sat to his left, an intelligence officer named Peterson, who had appeared at the facility from somewhere without being announced, sat to his right with a tablet and a recording device. "Tell me how you made that shot," Voss said. "I aimed and pulled the trigger," she said. "That's not an explanation. It's the only explanation I have." She looked at him steadily. Her hands, folded on the table in front of her, were perfectly still. "You want me to describe the physics? I can't do that. Your system describes the physics. It's very good at that. What I did wasn't physics." "Then what was it?" She looked at him for a moment. "When you've done something enough times, in enough different conditions, you develop a feeling for the sum of all the conditions at once. Not a measurement of each variable, the whole picture. Your system measures 14 different things and then combines them. I've been combining them for a long time, and I do it differently." "You were measuring the wind," Marsh said. "I was reading it," she said. "There's a difference. A measurement tells you what the wind is doing right now at that specific point. Reading it tells you what it's going to be doing in 4 seconds at a different point, which is the information you actually need." Marsh looked at his tablet. Then he looked up. "The scope on that rifle was cracked," he said. "You didn't have any optical magnification." She said nothing. "You made a center hit at 3,218 meters with a cracked scope." She said nothing. Peterson leaned forward. "Ma'am, I need to ask you something directly. What is your full name and occupational history?" "Martha Hale, contract medical support, 14 years. Prior to that," she looked at him. "Prior to that is prior to that. We'll need to verify." "Yes," she said. "I imagine you will." Morrow had been standing at the back of the room. He had not been invited, but no one had told him to leave. He watched her as Peterson began making calls, watched the way she sat at that table with her hands folded, entirely calm, as if she had sat in rooms like this before and found them neither threatening nor particularly interesting. He watched her hands. He had watched those same hands hold the rifle. He had expected them to be steady in the professional sense, the practiced steadiness of someone controlling an involuntary tremor. He had expected effort. What he had seen instead was something else. He had seen hands that were simply still, not holding still, simply still, the way something is still when stillness is its natural state, not a condition imposed on it. He thought about the slight tremor he had noticed when she first arrived, carrying the cooler, setting it down. He thought about how it hadn't been there at the rifle. He filed that away without speaking it. Peterson's call took 47 minutes. He came back into the briefing room and sat down and placed his tablet face down on the table and did not speak for a moment. "Martha Hale," he said finally. "Born 1963, Laramie, Wyoming. Nursing degree from University of Wyoming, 1986. Board certified, emergency medicine, 1992. Contract medical support contractor, Tier 3 clearance, since 2009. He paused. Prior to the nursing degree, prior to 1986, he placed the tablet face up on the table. On it was a service record, classified, the kind of document that was not supposed to leave certain servers. Its existence in Peterson's hands, in this room, was a measure of how quickly things had moved in the last 2 hours. Voss read it. Marsh read it. The room was quiet. Martha Hale sat with her hands folded and her eyes on the middle distance. The record was not long. Military service records for special operations personnel rarely are. The details exist in other places, in other systems, and what makes it onto the formal record is the skeleton, dates, designations, classification levels, commendations too significant to omit entirely. The record showed enlistment in 1980, at 17, with a parental consent waiver, training progression through conventional and unconventional warfare programs, a deployment record that consisted mostly of redacted location fields and date ranges that did not match any publicly known conflict timeline in any clean way, and a designation, SSOC Special Skills, Precision Engagement, codename, Desert Echo. The record showed active service through 1985. It showed a commendation for an engagement in a location listed only as Northern Theater, Operation Redacted, a precision engagement at a verified distance that Marsh read, looked up at Voss, and then read again to make sure he had parsed the number correctly, 3,740 meters. No AI, no wind sensors, no atmospheric modeling. A bolt-action rifle, a scope, and a woman who was 22 years old and could read air the way other people read faces. After the commendation, a gap in the record. 3 months. A medical leave code that corresponded to psychological evaluation and extended therapeutic support. Then, a separation from service, honorable, with full benefits. Then silence until a nursing degree in 1986. Voss sat back in his chair. There was an incident, Peterson said. He had a summary document. He placed it on the table without reading it aloud. Voss read it. He read it carefully. Morrow could not see what the document said. He could see the effect it had on Voss, the slight change in the angle of his shoulders, the thing that moved across his face that was not quite any single expression. He looked at Martha. She was looking at the table. "You left," Voss said. "Not as a question. I left," she said, "because of the incident, because of what I understood about myself after the incident." She was quiet for a moment. "I had been very precise for a long time. I calculated everything. Wind, distance, elevation, temperature. I was very good at it. And I made a mistake. Not a technical mistake. A human one. I was given incorrect target identification, and I didn't question it the way I should have, and a man who should not have died because of my precision." She paused. "I was very good at the calculation. I was not paying enough attention to what the calculation was for." No one spoke. "I became a nurse," she said, "because nursing is also precision work. But it is precision in the direction of keeping things alive. I found I preferred that direction. And today," Voss said, "today your young man brought me a rifle and looked at me the way people look at you when they need to believe that something is possible." She glanced toward Morrow. "I have a hard time refusing that." The decision was made at 1,400 hours. The ARAS team had spent the previous 2 hours attempting to address the algorithmic failure by rewriting the ground-level wind weighting parameters in real time. They had run 2 more test rounds. The first struck the plate frame, not the face, the frame at 1,341 hours, triggering a partial sensor response that the team initially logged as a hit before confirming it was not. The second, fired at 1,357, missed by 1.2 meters, which was an improvement, and also, in the context of what they were trying to demonstrate, completely insufficient. Voss stood in the briefing room alone for 4 minutes. Then he walked out and found Martha Hale, who was back at the ambulance, sitting on the running board, eating a sandwich. "There's a second target," he said. She looked at him. "It's at 4,023 meters, he said. "It was placed this morning for Phase 2 testing. We hadn't planned to use it today, she said. But the representative from the Program Oversight Committee arrives tomorrow morning at 0900 hours, and she will want to see a demonstration of the system's capabilities at the Phase 2 distance. He paused. The system cannot currently make that shot. We have established that clearly. She took another bite of her sandwich. Chewed. Swallowed. I'm not interested in proving anything to a committee, she said. That's not what I'm asking you to do. Then what are you asking me to do? He sat down on the desert sand. It was an unusual thing for a colonel to do, and they both knew it. He sat down in the sand beside the ambulance and put his elbows on his knees and looked at the desert. I'm asking you to show us something, he said. Not for the committee. For the record, for the people in there who have spent 4 years building a system they believed in, and who are currently sitting in a facility in the Nevada desert trying to understand why a woman with a cracked scope and no sensors outperformed their $1 million machine. He looked at her. What you did at 3,218 meters, that's not something I can log in the system evaluation report as human error. That's not something I can explain to Marsh's team as a fluke. They need to see what they think they saw. They need to confirm it. Morrow had followed Voss from a distance. He stood 15 feet away, not pretending he wasn't there. Martha looked at him. You started this, she said. Yes, ma'am, he said. She was quiet for a long time. The desert around them was in its afternoon character, vast, flat, indifferent, hot with the stored heat of 8 hours of direct sun. The air above the flat shimmered so heavily that the far ridgeline appeared and disappeared and reappeared, a geography that existed and then didn't, depending on the second. The thermal cycles out there will change in the next 30 minutes, she said finally. They shift as the direct sun angle decreases and the stored ground heat starts to dominate. There's a window of about 15 minutes where the low-level shear layer stabilizes. She looked at the sky. We have approximately 40 minutes until that window. Voss stood up. He brushed the sand off his trousers. Then we'll be ready, he said. Marsh met them at the firing line with a different rifle, his personal field verification piece, a heavy-barreled precision instrument that he had brought to the facility out of habit and never expected to use. He handed it to her without speaking. She looked at it. She looked at him. This is a fine rifle, she said. I know, he said. She settled at the firing position at 1,437 hours. The second target was visible on the enhanced camera display on the monitoring station. Barely it was smaller than the first target and farther, and the heat distortion made it appear and disappear with the movement of the air above the flat. At ground level, naked eye, it did not exist at all. It was a concept located somewhere at the base of the far ridgeline. She was still. The engineering team stood in a loose arc behind the firing line, none of them quite willing to commit to an expectation. Marsh had his tablet. He was watching the atmospheric sensors. He was watching the exact data streams that had failed 6 times today. He was watching them, and he was also, for the first time, trying to see what they weren't measuring. She moved the barrel. A small adjustment, up and slightly right, more than she had adjusted for the first shot. She waited. The wind at ground level did something. Morrow saw a subtle shift in the way the nearest sage stems were moving, a momentary stabilization, as if the air had briefly made up its mind. She fired. The sound rolled out across the flat and came back off both ridgelines, overlapping, creating a brief layered echo that decayed slowly into silence. The impact sensor on the second target 4,023 meters downrange triggered. Peterson, who had been standing near the monitoring station, looked at the telemetry readout and said nothing. He looked at it for a long time. Edge of the plate, he said finally. Outer third. But it's a hit. 4,023 meters. No electronics. No AI. No sensors. One shot. Marsh stood at the monitor with his hands at his sides for a long time. No one spoke. She put the rifle down on the table beside the firing position. She didn't hand it to anyone. She placed it down, carefully, with both hands, and then she straightened and looked at the far ridgeline for a moment. Something in her face during that moment was private enough that Morrow looked away. When he looked back, she had already picked up her medical bag. The ambulance needs to return to base before 1700, she said. Shift regulations. Voss was standing 5 feet away. He was looking at her with an expression that he was not quite in control of, the expression of a man who had spent 30 years building a worldview, and was now, in the late afternoon of a Nevada August, being asked to accommodate information that didn't fit into it cleanly. Martha, he said. She stopped. What you demonstrated today. What I demonstrated today, she said, is that there are things a machine can measure and things a machine cannot. That's not a discovery. That's a clarification. She adjusted the strap of her medical bag on her shoulder. Your system is a remarkable piece of engineering. The problem isn't that it measures too much. The problem is that it believes measurement is understanding. Marsh looked up from his tablet. He had been scrolling through the shot data, comparing the 2 shots she had made against the 6 the air system had attempted. He looked up and he looked at her and he did not say anything. But the look on his face was the look of someone who had just understood something that was going to take a long time to fully think through. The algorithm classifies the ground-level wind as noise, he said slowly, not to her, to himself. Because in the training data, in standard conditions, it is noise. It doesn't affect the outcome significantly, but in extreme thermal conditions, it becomes the dominant variable. The system was trained to ignore it. Yes, she said, because the people who trained it didn't know it mattered. Because the people who trained it, she said, had never stood in 110-degree heat and watched sand move. She walked back along the service road toward the ambulance. The sun was lower now, the angle of light changing, the shadows beginning to stretch long and thin across the desert floor. The heat was still tremendous, but it had a different quality in the late afternoon, less violent, more settled, as if it had achieved what it came to do and was now simply persisting out of inertia. Morrow walked after her. "Ma'am," he said. She stopped and turned, looked at him. "You're not going to get any credit for this," he said. "The report will describe anomalous atmospheric conditions and an unplanned technical evaluation. Your name won't be in it." "I know," she said. "Doesn't that?" "No," she said. He looked at her. "Why did you come out here?" "I mean the original reason. The contract work." "Same reason I do most things," she said. "People needed water and it was hot." She looked at him for a moment. "You're going to stay in this work?" "Yes, ma'am." "Then listen to what the data tells you, and also watch what the data doesn't tell you. Those are 2 different skills. You need both." She got into the ambulance. The engine turned over. Older engine sound, slightly rough. The sound of something that worked because it had been maintained, and not because it was new. She drove away down the service road, raising a thin line of dust that the late afternoon air pulled upward and dispersed. Morrow stood and watched the dust until it was gone. Behind him, the R's platform sat on its stabilized mounting, connected to its processing unit, connected to its 14 atmospheric sensors and its LiDAR rangefinder and its machine learning algorithm trained on 12 million rounds. It sat there in the late desert light, surrounded by 8 engineers who were very good at their work and who were now, quietly, trying to figure out what their work didn't know yet. Voss stood at the edge of the shade structure and looked at the desert. His hands were at his sides. Marsh pulled up the post-shot analysis on his primary monitor. He looked at it for a long time. Then he pulled up a new document and began typing. He would work late tonight. He would probably work all week. The report he eventually produced would not mention Martha Hale. It would describe in careful technical language an identified limitation in the ground-level wind characterization model and propose a methodology for addressing it. It would be a good report, accurate and thorough, and it would improve the air's system significantly. It would not be able to explain what she had done. That was the part that would stay with him. Not the failure of his system. Failures were data, and data was what he worked with. What would stay with him was the moment she raised that rifle, in the cracked scope silence of the afternoon heat, and the way she became still. The particular quality of that stillness. He had spent 4 years building a system designed to eliminate the variable of human imprecision, and what he had watched was not imprecision eliminated. What he had watched was precision of a kind his algorithms could not represent. Precision that did not come from measurement but from understanding. Precision that had been built not in a laboratory but over decades of standing in places exactly like this one and paying attention to things that were not in any training dataset. The machine measured. She understood. He was not sure, working in the field he worked in, how to quantify that difference. He was not sure it could be quantified. He was, for the first time in a long career of building systems designed to make such questions unnecessary, genuinely unsure how to proceed. He typed his notes. Outside, the desert moved through its late afternoon rhythms, unhurried and indifferent. The heat came off the flats in long, slow pulses. The sage moved at the base in a different direction from the tops of the stems, the way it always did in these conditions, the low-level air making its own decisions independent of everything above it. Somewhere on the service road, a cloud of dust was dissipating in the evening light, and Morrow stood at the edge of the firing line and looked at the distance at 3,000, 218 meters of desert air that had done something today that no sensor had measured correctly, that no algorithm had modeled accurately, that one person had read the way you read something you've loved and feared for a very long time. He looked at it for a while. Then he turned and walked back toward the work.